Okay, this will be an overview of page 1 and 2 of our Unit 1 notes. We have two vocabulary words, individuals and variable. Individuals are the object being described by the data. A variable, in this case, is the characteristic of one of the individuals. We have some notes on the bottom that are basically describing a set of data. So we always plot our data. And it says, don't forget your socks. That is an acronym. S, shape. O, outliers. C, center. And the last S is spread. Okay, in terms of shape for these graphs, the center of the data is approximately here. And this tails to the right, which means the graph stretches out further to the right than it does to the left from the center. Whenever you have this tail to the right, we call this a right-tailed graph, it would be skewed right. And vice versa, if it tails to the left, in other words, it stretches out from the center more to the left than it does to the right, it would be skewed left. So we've got right-tailed, skewed right, left-tailed, skewed left. This one has the word symmetric next to it. Now you have to be careful because it might not be perfectly symmetric. Sometimes we say approximately symmetric or roughly symmetric. This will be more of a bell-shaped curve where the center of the graph almost perfectly cuts the graph in half, and it looks, like a mirror image on either side. Outliers. Outliers are any unusually high or low values. We always want to look for them in our data, and we want to try to explain them. Now, to be able to tell if a part of the data is an actual outlier, there's a calculation on page 44 that you can go through to calculate whether or not it is an outlier. We'll go over that later. Center. Measures of center are mean, median, and mode. Now, we won't often use mode, but mean and median we will use. Mean we'll use if it's roughly symmetric. Median we'll use if it's skewed left or skewed right. The last S, spread. There's different measures of spread. The simplest one is the range, where you take the largest data point and subtract the smallest one. Or there's the IQR, which is the Q3 or third quartile minus the first quartile, and IQR stands for interquartile range. And then this SX, which is sample standard deviation. And we'll get into calculating that and using that as a measure of our spread a little bit later. Page 2. Once again, whenever we're carrying out an exploratory data analysis, you should always plot your data, always. A plot of the data gives us a quick glance at the distribution of the variable, the value it takes on, and how often it takes on those values. Okay, once it's plotted, we'll use our acronym SOX, shape, outliers, center, spread, for the data on hand. We have several types of plots to choose from. Which plot we use depends on the type and amount of data we're dealing with. If we have categorical data is data that places individuals into groups. So not so much a numerical, but more of a grouping, like gender, male and female, or hair color. You could have various types of hair color. There's lots of other types of categorical data we could use, eye color, shirt color, any kind of color that would separate it, ethnicity, and those types of things. Whenever we have categorical data, we're going to either use a bar graph or a pie chart to represent it graphically. Quantitative data. Those are numerical values that measure some characteristic of each individual. Some examples of quantitative data would be someone's height in centimeters, or an annual salary in dollars, maybe a grade point average, an ACT score, something that is numerically measured. So if we're going to use graphical representation for quantitative data, we use a dot plot or a stem and leaf plot. or a box plot, or a histogram. And we're going to make each one of these graphical displays in the next few pages of the notes. Now below, if we were in class doing these notes, I would say, let's list some categorical data that we could gather from our class. Some people might say gender or hair color, like we had above, or maybe eye color, colors of people's shirts, ethnicity, those types of categorical data that place individuals into groups rather than using some kind of a numerical separation. If we're going to collect data for that, we would say, let's say we're going to do shirt color. We write down every shirt color we have in the room and then put check marks for how many of each one we have. Okay, quantitative data, such as age or shoe size, height, weight, GPA, annual salary in dollars, other things that we mentioned above. Stuff that is measured numerically. So if we're going to collect quantitative data from our classroom, let's say we're going to collect it on age. So we write down everybody's age in the class, and then we group the 16s and the 17s and the 18s and the 15s together. See how many of each that we have. If we're going to do GPA, we write down everyone's GPA. And if some GPAs, let's say someone had 3.5 and someone else also had 3.5, then we'd have 2 in that